whenever you see problems that look this complicated, know that factoring is the solution. Factor everywhere you can.
Okay.
Okay?
Yeah.
Don't make the mistake of multiplying that by the numerator.
Okay.
You'll then have a cubic divided by a quadratic, and that'll be awful
Yeah.
to try to solve. Whereas if we factor first, in other words, we're looking at a quadratic there that can be factored, and we're looking at a quadratic there that can be factored.
Okay.
And if you had to guess what one of the factors is, what would you guess?
X minus, yeah.
Well, x plus 5, because it's going to cancel out. In other words, once you factor all of these, here's what we end up with. X plus 5, factor the top. That's different than square.
Yeah, x minus 6 and then x plus 6.
Now your bottom, I don't need to draw the line all the way over. I can draw it just there.
Okay.
Factor the bottom, knowing that, boy, we're looking for these kind of linear factors. What's the...
Yeah.
What is the...
X plus 5 and then x plus 6.
Yeah. In other words, it makes it easier to factor these things when you kind of know what one of the factors has to be. And now you can just cross out like crazy, and you got your answer, x minus 6.
Cool.
Okay. So, number 2, we're looking at 4 quadratics. Oh, this is a cubic.
Yeah.
But the solution is still the factor. Okay, so let's start with the top left.
Cool. Okay.
Let me do
so it'd be, so it'd be x minus 2, then x plus 1.
Top left, the only thing you can factor out of that is a greatest common factor.
Yeah.
Of what?
X.
Okay, what's left?
Hold on. Yeah, so it'd be x and then x minus 2.
And then check. Is that correct?
It is.
Okay, good. And that's what you always want to do, is check at each step of the way.
Cool.
Because if you wait until the end of the problem, you won't have any idea where you made a mistake if you make a mistake.
Yeah.
What's the bottom factor into?
X plus 1 squared.
Well, let's write it this way.
Yeah.
You know we're going to probably find another x plus 1 somewhere.
Yeah.
Now factor the top right.
Okay. This one would be x plus 3, then x plus 1.
Ah, we already found an x plus 1.
Yeah.
Cancel with one of those. You see why I didn't want to write it squared? It's actually easier to cancel if I don't write it in the traditional manner. Now, the bottom right.
That one would be
the greatest common factor you can take out of that.
2.
So it's 2 times x cubed plus 27. What's that called?
That's a cubic function.
That's the sum of perfect cubes.
Oh, okay.
Like difference of perfect squares, or the difference of perfect cubes, only it's the sum of perfect cubes.
Okay.
And that factor is a little different.
Yeah.
In other words, here's the way sum of perfect cubes factors.
Okay.
There's the perfect cubes. First term is always linear, just like difference of perfect squares, and it always has the same sign as what we started with.
Okay.
Second term is a quadratic. That always the middle term is opposite of whatever this sign is.
Yeah.
So that's how sum of perfect cubes factors. So how does x cubed plus 27 factor?
X squared plus 9.
Hold on. First term is a plus b.
So.
What's a?
Oh. x, right?
What's b?
27.
No. b
Uh,
cubed. b cubed is 27.
okay. So 9. B is 9.
b is 3. The cube root of 27 is 3.
The cube root. Yeah, I was thinking
Huh?
some. Okay.
Always when you're looking at sum of perfect cubes, the way you get a and b is to take the cube root of that is a. That's how you got a equal x.
Uh-huh.
And then you take the cube root of that, and that's b.
Okay.
You can do it on your calculator if you like, but they usually give you simple enough numbers that
Yeah.
you should know what the cube root of 27 is. So
Yeah, for
a
sure.
plus b is x plus 3.
Uh-huh.
What is the rest of it?
And then x plus x squared plus.
Not plus.
Or so it'd be x squared plus
Minus.
or minus 3.
What's a times b?
Wait. Um, 27x.
There's a, there's b. What's a times b?
Oh, 3x. Yeah, my bad.
And what's
And then it would be
b?
plus 9.
Okay. So I'm going to replace that x cubed plus 27 with that.
Okay.
All right, and I'm just going to do it like this so I don't have to rewrite everything.
Okay.
So here I'm going to put x plus 3
Uh-huh.
times this quadratic. And incidentally, this quadratic can never be factored easily.
Yeah.
When it comes from sum of perfect cubes, don't even bother trying to factor that. It will never factor.
Okay.
Okay? Now the problem's pretty easy. Just going to cross everywhere we can cross. In other words, normally I would say, well, I see a quadratic in there, I need to factor it, but not the quadratic that comes when you've factored sum of perfect cubes. Okay, so I can cancel that with that, that with one of those, and what am I left with? I'm left with, and let's leave it factored. The only thing left in the numerator is that.
Yep.
What's left in the denominator is this x plus 1 and a 2 from this 2 and this quadratic, x squared minus 3x plus 9. And that's as far as I can go.
Yep.
I cannot cancel anything else out.
No.
I could multiply everything together, but factored answers are actually better than multiplying them back. The only time you ever multiply stuff back together again is if it would allow you to simplify.
Okay.
If multiplying this numerator together gave me this quadratic, then I would do it because then I could cancel it.
Yeah.
But to cancel stuff, they have to be exactly the same. And everything has to be being multiplied or divided. Notice that when I was canceling up here, I got no addition going on outside of the parentheses.
No.
In other words, if I tell you I got x plus 1 over x plus 2, I cannot cancel those x's because I got addition going on there and there. I got addition going on up here, but it's all inside the parentheses. So I can cancel out an x plus 1 with another x plus 1.
Yeah.
But I can't do anything with this x minus 2 and this x plus 1. And this does not have any integer factors. Might have irrational, like square root factors, but that doesn't do any good to factors. So.
No,
But
for sure.
That's your answer for 2.
Cool. Okay.
And let's see. Guess we'll just go through each of them, huh? Because you got this. You say this isn't due till Thursday, and
yep, he decided to schedule a freaking quiz on Thursday before finals, so it's like.
Well,
so I have to study this plus review.
Early. I like that idea actually, because if he didn't do that, everybody would wait. If your finals are next Wednesday, everybody would wait till next Tuesday to even start.
That's true. It's just like,
The fact that
so
you
he
passed
gives
this
out,
test
yeah,
forces you to start preparing for that final a little ahead of the game.
yeah, for sure.
Okay?
But
All right.
he gives out, yeah, so this review plus math homework, like out of the book, and then plus the review for the
Mhm.
final. So
All
it's,
right. I presume we probably want to just do every one we come across, even though once we've done similar problems, you should know how to do this now. Why don't you tell me how
oh
to
yeah.
do 3?
Number three, so we would do, um, well, we'd factor out the top.
Okay?
The
Back to
greatest
that
common
top.
factor is 3.
Okay?
Um,
Leaving,
yeah, so it'd be 3 and then x squared minus 4.
does that factor?
Yep.
Okay, factor that.
Um, oh yeah, and then it would be x minus 2, and then x plus 2.
See, that's the difference of perfect squares.
Yeah.
Very similar to the difference of perfect cubes or the
Uh-huh.
sum of perfect cubes. But you do need to memorize those formulas unless they're going to give them to you.
Okay.
Are they going to give them to you?
I don't believe so.
And then let's
No.
go through them because I can show you a nice way to memorize them.
Cool.
You know what this one is, right? What is it?
Uh, oh yeah, so it would be,
Forget
uh,
for a minute. Well, I'll leave that there, but I want to
okay.
go through how to teach you to memorize these.
Okay. So it'd be a plus b, and then,
I
um,
don't like memorizing it like that. I like memorizing it a minus b times a plus b.
okay.
And there's a reason.
Okay.
The reason is that whether you're doing difference of squares, difference of cubes, or sum of cubes, they
Mm-hmm.
all have a very similar pattern.
Mm-hmm.
First term's always linear, and it always matches the sign. That's why I like putting the a minus b first,
Okay.
because it matches the pattern. This is also a minus b. This is a plus b. So it's real
Okay.
easy to figure out the first linear factor.
Mm-hmm.
Now, the second term is always a quadratic if you're dealing with either of these two.
Mm-hmm.
And it's always a squared, and then the sign of the middle term is opposite. So it has to be plus.
Okay.
Not 2ab, it's ab.
All right.
Always plus b squared, and this one, very similar, a squared, sign of the middle term is opposite.
Uh-huh.
And there you go. And
Okay.
that's why I generally correct a student, even before they've gotten to the difference of cubes or the sum of cubes. If they tell me the difference of perfect squares is a plus b times a minus b, I'll usually correct them and say, try to remember that as a minus b times a plus b.
Okay.
And it's hard to explain why if you haven't studied difference of perfect cubes, but once you see all three of them, you should notice a really clear pattern here,
Yeah.
which should allow you to memorize it. The only tough part to memorizing it is this part here. And
Mm-hmm.
then once you memorize this part, you know this part is almost exactly the same, only the sign of the middle term is different. Notice the sign of the front and the last term are both the same. They're both pluses.
Mm-hmm. Okay.
Okay? So
Mm-hmm.
just remember, always start out with the linear factor using the same sign as the original thing had.
All right.
Okay, so
Cool.
back to this problem here.
Yeah.
I hate it when it does that. Okay.
Yeah, me too. God.
Yeah, that's annoying. That's a software bug. That's all that is. I mean, I
Yep.
started with it and with two windows like that. And so all I did was I expanded it, but then when I recollapsed it, it didn't collapse into the same position.
Jeez,
So,
yeah, that is a bug, yeah.
yeah, so now we've factored the top.
Uh-huh. And then the bottom, we could factor that, like greatest common denominator.
Greatest common factor. So what is it?
Or factor, my bad. So it'd be 5 and then x minus 2.
Okay.
And then for 2x plus 4, it would be 2 times x plus 2.
And now, what's your answer?
So it would be 3 over 10.
That's it.
Yeah.
And that's for all x, no matter what x is. Now there are a couple of values that x can't be. In other words, there are some domain restrictions there.
Yeah.
X cannot be positive 2 because it makes this 0, and x cannot be negative 2 because it makes this 0.
Right.
So this is not quite the complete answer. The complete answer is 3/10, but x cannot be 2 and plus or minus 2.
Okay.
Okay. If you didn't put that domain restriction on there, you might actually lose a point.
Interesting. All right.
You wouldn't lose full credit, but you might lose partial credit.
Okay.
I'm not sure. That probably depends on the teacher.
Yeah.
All right, let's look at number 4 because it's a little different. It's got x's and y's.
Yeah, that would be a bit of a problem. But...
Tackle it one thing at a time.
Okay.
Tackle the numbers first.
Mm-hmm.
So what's 21 over 5 times 35? Can I simplify that at all? I can divide this by 3 or 7.
Yeah. By 7.
I don't think I can divide. Oh, I can divide it by 7.
Yeah, 7 times 3 is 21.
3 over 5 times 5, so that becomes 3/25.
Yeah.
Okay. And that takes care of all the numbers. Takes care of the 21, the 5, and the 35.
Uh-huh.
Now let's do the x's.
Okay.
I would say combine all your x's in the numerator, combine them all in the denominator, and then divide them. What do you end up with?
Okay.
What do you get in the numerator?
X.
Multiply x to the 10th times x to the 3rd.
X to the 13th.
Okay, let's go ahead and put that in there. And we still have this x squared down there. Let's go to the y's next.
Okay. So it'd be y to the 5th on the top.
And y to the 4th on the bottom. And now combine all of that. Still have 3 over 25. What's the net x's, and where is it in the numerator or the denominator? Where'd you got to combine those two now?
Okay, so it'd be x to the 15th.
Nope. When you're dividing, you don't add the exponents. You subtract.
Oh, you're doing. Okay, so it'd be x to the 11th.
Always remember that these things go together. In other words, if I'm multiplying the bases, I'm adding the exponents. Addition and multiplication are linked.
Okay.
If I'm dividing the exponents, if I'm dividing the bases, I'm subtracting the exponents because subtraction and division are linked. They go together. Subtraction is one level less than division. Addition is one level less than multiplication. So always remember that you're never doing with the exponents what's being done to the base.
Okay.
And then what about the y's?
And then the y's would be just y.
Numerator or denominator?
Numerator.
What they usually ask for on these problems is always give your answer with positive exponents.
Okay.
In other words, if I were to switch this around and make that y to the fifth and this y to the fourth, well, that would make it y to the minus 1. But that's a negative exponent, so I would move it to the denominator, and I'd end up with 3x to the 11th over 25y. In other words, if you end up with a negative exponent, just move it to the other side of the fraction bar. And that's true regardless of where it starts. In other words, if I've got 2 over y to the minus 4, I can just take that y and move it to the numerator with a positive 4. That's the same as that.
Cool.
And it doesn't matter whether this negative exponent starts out as a numerator or a denominator. I can always just take it to the other side.
All right, cool.
Change the sign on the exponent.
Okay.
Okay? All right, let's see. We got number 5. Division is exactly the same as multiplication because that's how I'm going to solve it. I'm not going to do any division at all. What's the first thing I'm going to do here? Besides factoring. If factoring wasn't the first thing, what would I do?
Well, you do same switch flip since it's division.
Yeah. So I would flip this and make it a multiplication problem. Well, then it's exactly the same as these.
Okay.
Okay, but let's go ahead and factor. How's the left factor?
It'd be x. Well, x. Because like it needs to multiply to minus 24.
You need to learn how to factor. You are not going to be able to go anywhere from this point forward in math unless you figure out how to factor.
Yeah.
You've had problems with factoring for 2 years.
Well, yeah.
You have. And part of that might be my fault because I think they teach you a different method in class than I've taught you. And I don't know the method they teach you in class because I threw it away a long time ago because my method works so much better as far as I'm concerned.
Yeah.
Problem is that most kids get caught between my method and the method they learned in class. And if you know the method you used in class, then by all means use it. I have no interest in you using my method. My method is no better than their method. They both produce the same answer, but you need to learn a method. You can't keep coming to these simple quadratics and not be able to do them.
It's x plus 12 and then x minus 2.
Okay. Now, did you do that using the method they taught you?
Yeah.
Okay. That's good. Yeah. That's fine. Like I said, I have no problem with that. Now, I'm going to multiply that by the flip of this. So the 3x minus 36 is going to be in the numerator. Factor that.
Okay, so it would be 3 and then x minus 12 in parentheses, and then it'd be x minus 12 and then x plus 12 in the denominator.
Good. And there's an x plus 12, and there's an x plus 12. There's an x minus 12 and an x minus 12. So I end up with 3 times x minus 2 in the numerator. What do I end up in my denominator?
Just 1.
Okay. What are the restrictions on this? What can x not be?
Plus or minus 3.
No.
Let's see.
If we look at the original problem, this 3x minus 36 is going to be the only restriction.
Yeah.
Okay? That's what can't be 0. So x cannot be equal to 12.
Oh, okay.
That would make this 0.
All right.
Notice that if I go up here, it looks like x can't be plus or minus 12. But that's not true because we weren't originally dividing by this. We were originally only dividing by this. It was only when I flipped it that the x squared minus 144 became a denominator. But that does not affect the domain. In other words, that's just a tool to do division.
Mm-hmm.
It's not the exact same thing. In other words, I can't flip that, make it multiplication, and say it's exactly the same problem. It isn't. Because once I flip it, make it multiplication, now x can't be either plus or minus 12. But that's not a true statement. The only thing I know for certain is that originally I was dividing by 3x minus 36, so that's the only thing that can't be 0.
Okay.
And that only happens when x is plus 12.
Oh, okay. That makes sense.
So this would be, I don't know if they're going to make you put these domain restrictions on there or not. I really don't know.
I think so. Like, we haven't really talked about
it. When I think of all the tutoring I've done in the last 8 years, I don't remember people having to put these domain restrictions on there.
Yeah.
So you probably don't have to worry about that.
No.
All right, we got time for one more here. I got 8:30 that I got to go to, but factor the top left.
Yeah, I got 7 parentheses x minus 3x. And then the
greatest common factor is 7x.
Or 7x, yeah.
Leaving x minus 3. So that's the top left. About the bottom left. Factor that.
X minus 7 and then x plus 5.
Good. So you do know how to do it.
Yeah.
I wonder if you could
I was just thinking on the...
trying to figure out how to do it by my technique.
No, it was just for number 5. I was, for whatever reason, thinking of 6 and 4.
Okay.
It didn't dawn on me that 12 and 2 also went into it, so after I figured that out, I was like, yeah, I know how to do it now.
So when I turn 6 into a multiplication problem, I get this. Now I can cancel that with that. What can I do with this x here? Can I do anything?
You can, can't you?
Yeah, because this is an x squared. That's an x. So I can cancel that and reduce the exponent by 1.
Yeah.
So now...
So it would be 7x...
Yeah, let's leave it factored. No strong necessity to multiply those two together. Down here, I still got that x to the 1, and I still got the x plus 5.
Yeah, and that's...
And again, everything is multiplication or division here, so I can do all these cancellations. In other words, I don't have a plus 1 being added outside the parentheses or anything.
Right. Yeah.
All right, so that ends up being a good final answer.
Perfect. All right.
Yeah. All right, Dylan, I will let you go, and tomorrow night, right, is our next session?
Sounds good. Is it tomorrow night?
Well, we changed, I think, to Tuesday. Let me have a look here before.
Might have, yeah.
No, we left it on Wednesday. You must have known your test. Good thing, because I don't have tomorrow night open. But
for sure.
Yeah, so I'll see you Wednesday at 8.
Okay, sounds good.
All right, Dylan. Bye-bye.
All right, thanks, Mr. Cowan.